Okay, here we go. Chapter 9 review. Bummer thing, just did the whole thing and there was no audio. So I'm doing it again and now I know I can make it shorter. So for you, it might be better. So I'm going to try to be a little more brief than my first time through. Okay, warm up. I am just going to do this. This is stuff you should know how to do. You should be able to figure out what the hypotenuse is, either because you know it's a pith trip or you use your Pythagorean theorem. You should know these original trig functions because they are ingrained in your head by whatever method. And go ahead then and label up a triangle and realize what your opposite adjacent are and be able to plug in. I'm not going to do this because I believe you can do this. This gives me an opportunity though to review. We met some reciprocal trig functions. So the recip to sine is cosecant, so you just flip sine. The recip to cosine is secant, and the recip to tangent is cotangent. So if you just remember, if you know one and you want to know its reciprocal, you just flip it. Okay, let's get into more of what we're talking about in this particular chapter. As I've talked about in class, I gave you a piece of paper that looks just like the beginning of the test, so you should be able to fill in all these blanks. I am not going to do it here. I want to highlight something though. And if you want at any point, you should stop the video and try it and check it on your own. This one I'd have you check on your own. We did in class talk about the relationship between 30 and 60, and it really has to do with this whole sort of concept of the 45-degree angle, which is really like y equals x. And so what we're really doing here is reflecting over y equals x. So it is a fact then that the sine of 30 should be exactly the same as the cosine of 60. And the cosine of 30 is the same as the sine of 60. And the interesting relationship here really is that these guys, geometrically, 30 and 60 are what we call complements. And so for the same reason that we're reflecting this point at 30 to 60, the same thing would happen with 20 and its complement, 70. So you might want to try that on your calculator and start seeing that relationship. Which leads me to a little extension problem here, where you're asked to write the sine of 100 as a positive acute function value less than 45. So normally we're looking just for a positive acute function value. So this is kind of upping the ante. I'll make it a little more difficult. So if I'm at the sine of 100, I'm just going to draw a picture, and I'm going to here to 90 and over here to 100. Hopefully you realize that to get to 100 I have gone 10 degrees beyond 90. So that means there's an angle over here, same amount, 10 degrees back, that would have the exact same sine value. So this would be 80. So it is a fact then that the sine of 100 should be equal to the sine of 80. And the signs are the same, SIG and S. They're both positive in quadrant 1 and 2, the y value. So in order to get to this function value, though, less than 45, I'm going to use what I was just talking about, and that is that the sine of 80 should be exactly the same as the cosine of 10. And that meets the requirement of being less than 45 degrees. And I'm going to prove that to you quick here on my calculator. So if I take the sine of 80 and I hit enter, I get a yucky decimal. And sure enough, when I take the cosine of 10 and I hit enter, I get that same yucky decimal. Okay, so onward. This is something having to do with the geometric representation of cosine and tangent that you should know. Lucky for you, you have a fancy calculator that will tell you these values. But in reality, if you draw an angle in the unit circle and you pin down these points that I've shown here on the board, it is a fact that the x value, if you were to measure it, if this was a to scale drawing of the unit circle, will be your cosine. It is a fact that the y value will be your sine. And it is a fact, if you extend the terminal side to the point where it crosses the tangent to the unit circle at this point 1, 0, this y value, this measurement here, is the tangent. And so I would describe that as CD. Now, angles land in different quadrants, so this is just another scenario. So in this particular case, we're in quadrant 2. The cosine is still represented by the x. And in reality, this is a negative x value. Even though we don't in geometry think of segments as being negative, we would call this a directed distance, and it's directed in a negative way. So to make this a negative cosine, because we're in quadrant 2. The sine still is this measurement here, the y value, which would be AB. And the tangent, which gets a little bit weird, is same rules. We need to extend this terminal side to where it crosses this tangent to this point 1, 0. And so now my measurement that tells me tangent is actually below the x-axis, which would be CD, as that's labeled. Now, in the world you live in, you don't really need to use this, but you do need to know it. So there you have it. Okay, angle and standard position terminal side goes to the point negative radical 2 over 2, radical 2 over 2. So hopefully at this point you realize we are on the unit circle with these values. And so the sine, as we have learned, is just going to be the y value. The cosine, as we have learned, is going to be the x value. And the tangent is going to be the sine divided by the cosine. So we have a positive radical 2 over 2 divided by a negative radical 2 over 2, which would give us negative 1. So now the next question here is, hey, what is this angle? So we have a couple options. One option would be to say, well, I know this is one of these 45-degree slices of one of the quadrants. So if I could just figure out what quadrant I'm in with a negative x and a positive y, I would be in quadrant 2. So my angle is this guy right here, which really is just 90 plus 45, also known as 135 degrees. Now another way to do this is you could come back, I would probably come here because it's the easiest thing to put in my calc, and ask my calculator to help me. But sometimes my calculator doesn't help me the way I want. So this is like saying, hey calc, give me an angle whose tangent's negative 1. So I'm going to go ahead and do that. I'm going to hit second tan, and I'm going to type a negative 1 in and see what my calculator has to say. And unfortunately it didn't say what I wanted it to. So you're going to find with your calculator, and this is why you really do need to be able to move around the quadrants, that your its favorite quadrant is quadrant 1. So if it can go there, it will. But there are no negative tangents in quadrant 1. And so what it is doing instead is it's taking us to quadrant 4, which you'll often see that to occur. So it's saying, hey, how about this angle down here? But in this particular case, we're trying to get ourselves into quadrant 2. So knowing what you know about the quadrants and positives and negatives, then that gets us up here where you can think of it as these guys are vertical angles. This is 45, so then this guy's 45, which then leads us back to that 135. Now, if you have something like this happen, but then you're trying to make sure that you've picked the right angle, then you can say, well, wait a minute, calculator, how about the tan of 135? Doesn't that get me into negative 1? And sure enough, it does. Okay, another possible question is just to give a positive and a negative coterminal. This is checking your vocabulary. So, positive coterminal, for me, I would just say, oh sure, I'll do that. I'm just going to add 360. And so 135 plus 360 gets me to 495. And if I want a negative, I'll say, sure, I can do that. I'll just go the opposite direction. So I'm going to take 360 off. And that takes me to a negative 225 degrees. Okay, next. Another thing we need to be able to do is quadrants. And so we've talked about different ways to remember this, besides just plain having a kind of an understanding about what's going on in the different quadrants. So first you have to be able to label the quadrants correctly. And all students talk constantly. So, what quadrants would I find tan positive? Well, everything's positive in quadrant 1, so I can go to quadrant 1, or, in this particular case, tangent's the only thing positive, so I could go to quadrant 3. Where do I find sine less than 0? Now I can use my little labeling here, or for me, really, when I'm thinking more of sine, I just say, hey, where are the y values less than 0? And so that would be in quadrant 3 or quadrant 4. Now, what if these two guys join forces? So basically, if I have this and situation, then my first step is really, well, where do I find tangent to be greater than 0. And if it was me, I would probably kind of do it like this. And I would say, oh, okay, I already know tangent's greater than 0 either in quadrant 1 or quadrant 3. But now I get to limit it, and sine has to be less than 0. And so I know sine is greater than 0 here, so that takes me to quadrant 3. Just another version of it. Maybe you're actually given real live values. You could try to figure out different angles, but I would just think of this as if cosine is positive. So if cosine is positive, I am either going to be in quadrant 1 or quadrant 4. So I would probably do something like this. So I got to look at these two quadrants, and if tangent is negative, tangent is positive in quadrant 1, so that takes me to quadrant 4. Exact values. This is where knowing your unit circle or knowing how to cheat on your calculator comes into play. So the sine of 60, for me, I think the sine of 30 is a half, so the sine of 60, it has to be this radical. Radical 3 over 2 plus cosine of 45, radical 2 over 2. Since I have common denominator here, this is an easy one to just join up. Sec of 60 plus cos 180. So this is an opportunity to show that you realize that cosine and secant are reciprocals. Cos of 180, either you can push the buttons on your calc or realize that the cos of 180 is this x value, which would be -1. So the cos of 60, and this is where sometimes I use some of these relationships, has to be the same as the sine of 30, which I know is a half. When I take plus and minus, I get -1. 1 over half is really what's the reciprocal of a half, which is 2, and 2 minus 1 is 1. Done. Okay, cos -160, write as acute positive angle. So once again, in the reference angle notes, I did give you the equations, but I think for long-term understanding, pictures really get the job done. So cos of -160, so here I go. -90, but I got to keep going. But I know if I go all the way to my x-axis, I'm getting to 180. So I'm going to get myself over here to 160, which is going to be 20 degrees shy of, no, it's not going to be 20 degrees, it's going to be 30 degrees shy. Okay, I'm at 90 and I'm going to 160, so it is 20 degrees. Okay, here we go. Because 90 plus 70 is 160. I take that back. Okay, so now I'm in quadrant 3. That's not where I want to be, because acute positive is quadrant 1. So basically, I want to just get this angle up here, because I want to be the same amount up as I am down, which would be 20 degrees. So that means that the cos of 160, the value of it has to be the same as the cos of 20. But this is where I need to be careful, and the reason I need to be careful is over here at -160 my cosine is negative, so in order to have the same value come out, I need to put the opposite of cos 20, because otherwise I'm going to have a positive value. So let me prove this to you, and sometimes playing around on your calc and checking what you think is the answer is the ticket to making sure you have done it correctly. So I'm going to go here and I'm going to type in what I started with, which was the cos of -160. And out comes a number. There it is in all its glory. And now I'm going to type in what I believe to be the answer, negative cosine of 20. And hit enter, and hopefully the same thing comes out, and sure enough it did. Okay, moving right along. Remember, stop this thing at any point if you want to try it on your own. This is just another problem I had on my paper that we've already talked about, but sometimes maybe you'll get some information, hey, the tangent's 1 and the sine's less than 0, what quadrant? So I'm just going back. So where do I find a tangent of 1? Basically, and for me, as far as tangent goes, like I know everything's positive here, and I know tangent shares the same sign. It's kind of kitty corner, so either tangent in quadrants 1 or 3. But then I need my sine to be less than 0, which means my y is less than 0, so that takes me here to quadrant 3. 1 is out. Okay, a few more problems. Express as a function of a positive acute angle. So once, hopefully you're starting to train yourself, this means get to quadrant 1 on the double. So I'm going to do this by drawing pictures. So the cosine of 100, if I start my trip here, I go to 90. I need to get to 100, so basically I've gone 10 degrees in the quadrant 2. That means there is an angle that is 10 degrees over here that will have the same cos value. So then this would be 80. So I know then that the cos of 80 is going to have the same value. Now the question is, does it have the same SIGN sign? And cosine of 100, if I type it into my calc, is negative. So in order to have this cos 80 come up with a negative in front of it, I need a negative, because cos 80 itself is positive. Okay, tan of negative 310. Same old here. So I'm going to start my little trip around my unit circle, notice in the other direction. So negative 90, negative 180, negative 270. So now I got to go further. 280, 290, 300, 310. So I have just gone 40 more degrees into this direction, which means then that there is an angle that's 50 degrees up above the x-axis. Now there's good news here, and the good news is that this actually landed me in quadrant 1. So it's a fact then that the tan of negative 310 should be equal to the tan of 50. And I am going to check that to make sure. So the tangent of negative 310, I'm going to hit enter, should be the same as the tangent of 50. Hit enter. And sure enough it is. Okay, so now, one last one. Sine of 300. Same thing. Positive is going counterclockwise. 90, 180, 270. I got to go a little further. 280, 290, 300. So I've gone 30 degrees into this zone. So that would mean that I have 60 degrees over here. So in order to get so that I have the same function value, and this is not the most beautiful looking sort of depiction of the unit circle, I know I need to go 60 degrees above. So this guy right here is going to have the same value. So the sine of 300 and the sine of 60 is going to have the actual same number value. Now the question is, if I hit sine 300 on my calc, I'm going to get a negative. So in order for this to come out the same negative, I need to put a negative sign in the front of it. Okay, a couple more. Cos theta is 0.2345. Find theta so that it's between 0 and 90, as in find quadrant 1. You may be asked to do this rounding to different ways. So say I'm asked to round to the nearest degree. So I'm just going to get my trusty calculator up again, and I'm going to say, hey calculator, tell me what angle has a cosine of 0.2345. So I'm going second cos, and I'm typing in 0.2345, and I'm going to hit enter, and out comes 76.4. This particular part of the problem is asking me to round it to a whole number, so that would be 76 degrees. Now if they ask me to round it to the nearest minute, I have a couple options. One option would be to get that 76 out, so I'm going to subtract the 76 and realize that this is the fraction before going to 77, and so if I multiply that by 60, it will tell me my minutes. So it's 26 minutes with a little more. So if I want to go ahead and write that down, then now I have 76 degrees, 26 minutes. And you'll notice, remember there's 60 minutes in a degree, that the reason it didn't round up is because this is less than 30. Now the other thing that we learned, if I come back here again, I'm going to hit clear and I'll just go through this process again. I'm going to hit second cos, I'm going to type in 0.2345 and I'm going to hit enter. If I actually hit second apps, I get this DMS, so I'm going to hit number 4 for degrees, minutes, seconds, and my calc will tell me what it is. But now in this case, since it's giving me seconds, I need to look at that and make sure it's less than 30, otherwise my minutes would round up. But I get my same answer there. So bottom line is you just never know how you may be asked to round, so be prepared for whatever. Okay, last problem. Say you are told the cosine of an angle is negative 0.3, but now someone's being very specific and saying, hey, find that angle in quadrant 3 to the nearest degree. So same starting point. I have no idea what angle goes with a cosine of negative 0.3, but my calculator does. So I'm going to come back here, I'm going to hit clear. And I'm going to clear this so you can see what I'm doing here. And I'm going to say, hey, calculator, tell me, give me an angle whose cosine is negative 0.3. Now, it tells me 107. So now I'm doing this to the nearest degree, so that would be 107 degrees. So I'm going to come back here hoping that I'm done, and I'm going to write 107 degrees, but then I notice that it's supposed to be in quadrant 3. So here comes the picture time. 90, and then I have to get to 100. So I'm at 90, I'm at 107. So basically I've gone 17 degrees beyond my y-axis. And unfortunately I'm in quadrant 2, not quadrant 3. So if I take 90 minus 17, I get, I do believe, 63 degrees. Do I get 63? No, I get 70. 63, 70, 80. I'm shy a little bit here. Okay, so this should be 73 degrees because 73 plus 17 is 90. So in order to get to quadrant 3 then, I need to think of an angle basically in the same position. So I got to come down here 73 degrees below. So if I take 180, because it takes me 180 to get here, plus 73, I will get myself an angle that gets the job done. So 180 plus 73 is 253 degrees. And I will have a cosine that's negative because in quadrants 2 and 3 my x values are negative. So this guy works. Okay, last problem. Same idea. Sine theta is 2/3. Find an angle in quadrant 2 that meets that requirement. So once again, I don't know what it is, but my calc does. So I'm going to hit second, sine, and I'm going to type in 2 divided by 3. And I'm going to hit enter, and out comes 41.8. Once again, this problem's asking me to the nearest degree. So I'm going to go ahead here. And it doesn't hurt. I should just make a point of like actually writing, you know, oh, it was 41.8. Because then if somehow you do some kind of crazy rounding, then you can like, the person grading, me in this case, can realize like, oh, they had the right thing, they just did some kind of crazy rounding. So quadrant 2 though is where I'm supposed to be. So 42 degrees is somewhere around here. So that means I need to find the corresponding angle that would be in a similar position over here. Because remember, this really is all about being in the same position as far as x and y values go. So in order to figure out what this angle is, I'm going to just take 180 and subtract 42. So 180 minus 42 is 138 degrees. And just to make sure that all is well here, I want to go back to kind of where I began and say, well, does that meet a requirement? Is the sign positive? And I say, I'm in quadrant 2. Sure it is. Okay, you have lots of other problems, you have review problems, you have extra problems we haven't done in the book which you have answers for, so you feel free to do any more practice that you need to for this test, and I'm happy to answer any questions.